Today, we are going to take you to Demmin, in the northeast of Germany. It's quite a trip from Berlin. At TU, Micha and Pia are preparing for the field trip. They need to make sure everything will work out as planned. Thus, they carefully check the weather forecast. Maybe not ideal, but it'll do. Charge all required batteries. Pack all equipment. Prepare protocol documents. And finally, load the car. See you later in Demmin, Micha and Pia. And here we are. Micha and Pia arrive at the study site, where some colleagues are already waiting. The study area is a mixed beech forest in northeast Germany near Demmin. Here, a 40-meter high crane with a 45-meter long radius allows access to roughly 100 by 100 meter site, and the canopies of about 300 trees, of which 75% are European beeches. As you can imagine, leaf sampling is challenging in mature forests. Taking advantage of a tower crane, the project FEMOFIS currently aims to fill this gap by developing a remote sensing-based monitoring procedure based on a physiologically founded vitality assessment of main tree species in mixed stands. Every year, the colleagues from TU Berlin, University of Greifswald, and the Landesamt Forst in Eberswalde perform 5 field campaigns during the vegetation period. This includes the sampling of 42 trees of the species European beech, pedunculate oak, Douglas fir, European larch, and Norway spruce. This includes spectral measurements and the collection of leaf samples for later analysis in the laboratory. Okay, enough background. Pia and Geraint are getting the crane ready. This includes checking the crane for visible defects, connecting power and wind equalization cables, checking the fuel level and starting the large crane generator, testing the rotation of the crane jib and the node end holding points, and finally, connecting the gondola. Meanwhile, Ephraim is preparing the sampling containers and safety equipment to go into the gondola. Oh, and Pia already unpacked our spectrometer. Once again, it's an ASD FieldSpec 3. Before anything else, she attaches the batteries and switches on the instrument, as it needs some time to warm up. The field spectrometer is quite a versatile instrument that we use in many different setups. Today, we'll use it with a plant probe accessory, including leaf clip. Pia connects the plant probe to the fiber optic cable and to the spectrometer for electricity. This device comes with an internal light source, meaning illumination is always stable and independent of weather conditions. It can even be carried out after sunset. Okay, we are ready to load the crane gondola. Pia and Ephraim load the spectrometer into the gondola and connect the instrument to the laptop. In the meantime, Eric unloads a big white box and places it in the gondola too. What might be in there? Well then, everyone who wants to go up in the gondola, put on your safety equipment and make sure everything is secure. Make sure to check your partner too. Ephraim places the laptop on a safety tray in front of his chest and turns it on. As always, we are using the software RS-Cubed High Contrast. Ephraim sets the storage location as well as the save and acquisition options. Ready? Here we go! Now we are getting very close to this mature tree. Measurements are taken at 3 positions per tree to cover more variability within the crown: treetop, north, and south. The branches selected are visible from above, to be able to compare them with images from drones, airplanes, or satellites, and marked. Eric carefully picks a couple of leaves, which he later analyzes in the laboratory for relevant biomarkers such as chlorophyll content or phenols. For now, he immediately estimates chlorophyll content of 5 leaves with a SPAD chlorophyll meter. The same leaves are to be measured immediately with the spectrometer. Therefore, Pia and Ephraim get the spectrometer ready. For calibration, the white side of the tiny reference panel needs to face the device. First, Ephraim needs to calibrate the instrument. Therefore, the spectrometer automatically measures the dark current, the instrument noise. Then, it performs a white reference measurement. The tiny white panel is now assumed to reflect 100% of the artificial light, so all subsequent leaf measurements are set in relation to it. Notice the beautiful straight line at 100% reflectance over all wavelengths? Now, during the measurement of leaves, the black side faces the device. The leaf is clamped with the upper side directed towards the light of the leaf clip, while no sunlight should enter. Per leaf, 3 measurements are taken and later averaged. Thanks to the leaf clip's internal light source, the measurements are largely unaffected by atmospheric interference, such as those occurring with drone or satellite acquisitions. The aim of these measurements is to find out if and what relationships can be found between the spectral field measurements and the phytochemical lab analyses. The leaves collected and measured by the spectrometer must be quickly frozen on dry ice to keep them fresh enough for phytochemical analysis later in the laboratory in Eberswalde. Aha! That is what the white box was for. As usual, don't forget to take notes on every data you collect, as well as anything you observe in the field, ideally on a previously prepared sheet. As for spatiotemporal monitoring of forest health, we need a wider view. We take a step back and look a little less close. Just a little. For upscaling at a small scale, measurements with the spectrometer are taken approximately 30 centimeters above the branch/tree top. These measurements are no longer conducted with the leaf clip and its internal light source, but are based on the reflection of sunlight, thus incorporating atmospheric interferences. It is ideally performed around noon on a cloudless day, when sun elevation is highest and shadows are few. Due to this limited time window, this measurement is performed only at one position at the top of each study tree. A white reference calibration is performed with the white panel before and after each measurement. Done! While Pia and Ephraim are busy collecting spectral data from the crane, Micha and Robert on the ground are getting the drone ready. The drones are a farther step away from the initially observed leaf level, and a step closer to satellite monitoring of forest health. If cloud cover allows, the TU team attempts to collect a multispectral and a hyperspectral acquisition per campaign, as well as one laser scan called LiDAR. Robert carefully attaches the hyperspectral camera and then performs the obligatory white reference measurement with Micha's assistance. A final check of the flight planning and we are ready for takeoff. Such a hyperspectral drone is actually quite big and heavy, isn't it? In addition to a compulsory flying license, Robert needs quite a bit of training and is the only pilot in the group. Here we go! From a bird's perspective, even the tall trees and the tower crane look small. While the TU team is busy measuring, let's follow Geraint around a bit and see what else is there. Like a large system of gutters to estimate rainfall under the canopy, or a lonely white box strangled by black pipes. Ah! A data logger! The black pipes lead to 41 of our tree friends, where Geraint and her colleagues have installed point dendrometers at some trees, even in different heights of the stem. These continuously measure the thickness growth, swelling, and/or shrinking of the trunk. In addition, sap flow sensors are installed at 12 different trees to measure, well, sap flow. And there are soil moisture probes too, to assess soil moisture at different depths, up to 1 meter. Finally, Geraint shows us another rather special measurement, so-called mini rhizotron tubes, which are scanned regularly to visualize fine root growth. Jeraine attaches the scanner to her tablet and checks the settings before she calibrates the instrument. The white tube serves as a white reference. Then, she cleans the risotron tube and carefully extracts the scanner from its reference tube and inserts it into the ground. Now, the scanner rotates in the tube by 360 degrees and scans the surrounding ground. Oh, do you see the small roots there? That is really impressive. Jeraine and her colleagues repeat these measurements every 2 weeks throughout the year. That way, they can monitor the fine root growth very carefully and observe the fine root's reactions to seasonal changes as well as weather conditions, which trigger growth but may also cause dieback of roots. Wow! Well, and that's it for the day. Pia secures the crane. It is important to check after the work is done that the crane jib can turn with the wind. Meanwhile, Ephraim secures the data acquired. Then, Pia starts a much smaller generator to charge the batteries for the next day, and Micha and Ephraim collect all equipment to be stored in the container or car. We quickly boil some water for instant noodles and tea while the generator is still running. And then we finally enjoy the silence in the woods. Good night.
Nee, da wird nichts mehr gemacht, weil da ist jetzt kein guter Beleuchtungsbetrieb mehr.